Okay, we're here with our student Rita to talk about functions and how to identify them. Ready to go?
Yes.
Okay, cool. So first let's talk about what a function is. And you can kind of visualize a function by taking a look at a diagram like this. So you have an input that you're going to put into the function, and you're going to get exactly one output. Not two outputs or five outputs or zero outputs, but one. Okay?
Okay.
And a function is usually going to be something kind of like an equation. So here's one. This is a linear function. It's y equals 3x plus 2. It's in the y equals mx plus b form. And you're going to put into that usually x, and you're going to get out of it usually y. So this is set up really well. So you can put something in for x, and then you can see what y would be. So you can put 0 in for x, then 1 for x, etc. And you get one output with a linear function like this. And other functions have just one output too. Make sense?
Yep.
Okay, so here you could put, for instance, 4 in for x, and then we would put that into the equation. So instead of writing x, we would write 4 in place of the x, just like we have here. And then we would get an output. What's 3 times 4?
12.
Plus 2?
14.
14. So then you would get the output of 14. Okay? Exactly one output, so this is a function. Okay?
Okay.
So let's take a look at graphs, tables, and sets to understand how to recognize when it's a function or not, okay?
Okay.
Okay, so first with graphs. So here is a graph of a line, and what we want to understand is there exactly one output for each x input? Okay, so if you think about it, looking at the graph here, each place on the x-axis has a value, and we see that there's just one y value for that. Each time we find an x, then we see there, oh, there's just one y value. So we can say that each input has exactly one y output, so that is a function. Does that make sense?
Yeah.
Yep, it is. Okay? Now let's look at another function here. So this is a graph of something that's kind of like a squashed circle. It's called an ellipse. And let's ask ourselves the same question. And we realize that some of the x inputs, for instance, if I look at this value here, x equals 3, well, y might equal this value up here, or y might equal this value down here, right?
Right.
So there's more than one y output for some x inputs. Okay, so is that a function?
No.
No, it's not. Okay? Okay, so that's how you can tell on a graph, is by just looking and see if there's more than one y output for each x input. How about with the table here? So here we have x's and y's, and we're putting in x's, and we're seeing what comes out with the y's. And if you notice, there's a spot here where we put a 1 in for x and we get 3. And there's another spot where we put a 1 in for x and we get 7. Okay? So what we can see is one x input, when we put in 1, has two different y outputs, 3 or 7. So is that a function?
No.
No, it's not, because it has two different outputs for one x input. Let's look at another table here. So here we see that we have some different values here, 1, 2, 3, and then also 1 again for x and 4. But each time we put in that 1, we get the same output of -2. So there's nothing to say that this is not a function. If this were all the values for a function, we would say, yes, it is a function. Each x input has exactly one y output, so yes, it's a function. Make sense?
Yeah.
Okay, now let's look when we're given values in sets. Usually we'd be given them in ordered pairs like this. So this might look like a whole bunch of writing, but basically each one of these, like 3, 3, is an ordered pair, just a point you could put on a graph. And then we gather them all up and we put the set brackets around them, just so that we can say this is a set of points. Okay?
Mm-hmm.
So when we look at this, we want to look and we want to see each x input and see if there's just one y output for it. And in this case, each x input has exactly one y output. There's not a place where we put the same thing in for x and we get something out different for y. So is that a function?
Yes.
Yes, it is. Okay, let's look at just one other one here. So we have, let's see, 0, 3, 1, -21, 2, 6, 0, 11, 1, 11. Where is there, this is not a function, you probably might have determined that. Why isn't it a function? What makes it not a function?
Well, for values like 0, there's two different outputs.
Yep, you put in 0, you get 3 the first time. Put in 0 later, you get 11. You can't have that with a function. So this is, some x inputs have more than one y output, so it's not a function, right? Understand?
Right.
Okay, great. So that's how you can recognize if something's a function or not. Good.